All right, ELE112. This is Chapter 19, Bode plot, Part 2. I thought it would be interesting to draw the Bode plot from scratch so that you can experience that going through one time. I want you to see on this slide that I have summarized the frequencies and the voltages out for each of them. Let me go ahead and get to a drawing tool here. That would be nice. Frequency develops a voltage out by solving it in the circuit, and we do a simple math computation to get to decibels. We can see that the resonant frequency is at 107 kilohertz, and as it moves away, it decreases. The fact that the decibel has a negative means there's a signal loss. These are, as we've said before, these are passive circuits, not active circuits. There's no power to the resistors and capacitors. The signal that flows through them is not a power supply, it's a signal. And so signal loss occurs going through, and you can see as we move down that the decibels get larger, or in this case, smaller and smaller and smaller. Even though the numbers get bigger, they're actually bigger losses as we move out in the frequency spectrum. Even at, I decided to do a couple of extra points at 30K hertz and at 400K hertz to support the measurements that we're making. And everything looks good. So let's go to the next page. Our data here, we see that we need to get as far down as minus 37 dB. The center is at 0, and it looks like we need to get as far as like 40 dB. So taking here, and we're going to plot this point right here at 199K is 3.4 is right here. 115 is basically minus rounded in there. I'm going to do the 10K at minus 30 go, and I'm going to grab the 1 megahertz, which is minus 30 to happen at the end. Okay, it's going to die. At 30K, it was rough points at 400K. It's about, an old guy like me can't remember. and start making one of these Bode plots. Okay? Okay, so this is going to be challenging to say the least with this little writing pencil that I have to work with. Let's give it a whirl. I'm going to start by saying that we need to locate where the resonant frequency is. That would be a good starting point. Now you look at this particular log, semi-log paper. And I want to say something about the paper. It's used because it's compressed in this direction. It means that the frequencies can get rather big because the graph is not linear. It's not linear in the left and right direction. Whereas going up and down in this direction, it's a linear plot. And that has to do with the data that we're taking is going to be compressed in the linear direction, and it's going to get rather large in the nonlinear region of frequency. So, you know, what I'm trying to say in plain English, and I'll draw you a picture here real quick, just a rough picture. Let's say that this is my Bode plot for a bandpass circuit. All right, it's just a random one that I decided to draw. See, nothing really interesting happens except in this region. And the roll-off that you see out here, we already know what it's doing going to the left, and going to the right. We already know what it's doing. So the roll-off encompasses a lot of frequency area or frequency content. And so we use this semi-log paper. You'll see as we start to draw this that, you know, for it to make sense, you have to have this compressed scale going left to right. Second thing that I see here, the actual frequencies. This is store purchased paper. You can buy it at the store. This was before the internet was created. You would buy this kind of paper. So yeah, it's been around a while. You'll notice that the frequencies don't work well with our range of circuit because we need to go to 400 kilohertz. We need to go to a megahertz, and we're not set up for that on this paper. So what we're going to do is these are just numbers. We're just going to add zeros and move things around exactly how we decide to have them. So I'm going to suggest that we start here, and I'm going to make this 10K, arbitrarily chosen, could have made it 1,000, and 10K will reach 100K, which will reach a megahertz, you see. So I've redrawn the scales the way I see fit, and I'm going to rub off the scales that the paper came with. This means you can buy this paper and it really doesn't matter what the scales say. Now, another tip that I have is label it. Label the Bode plot. Okay? So it would be called band pass response curve circuit number 1, or whatever your circuit's called. Bode plots usually have a label, a title, so that you know what you're doing. Okay, less important, but just wanted to say that so that you've seen it labeled properly. If you go on to ASU, you'll be doing stuff like that. Okay, next thing. I prefer to have the coordinates down here. 10K, 100K, 1 megahertz, 10 megahertz. And see, our plot doesn't even go out to 10 megahertz, but it's there. It's there on the paper. Let me go ahead and put that there. 10 megahertz. Okay, so now we're ready to rock here. If you take a look at the data points that we need to plot, I like to plot the resonance spot, which is at 107. That would be 100 here. And the next line, the next major division here is 200K. So if that's true, and I'm going to get rid of that, it's kind of messy here. There we go. Let's try it again. That's 200K. That's 300K. Up here at the top, that's 400K. I wrote it on the top because it's getting packed down below, and my little thing here for the computer doesn't write very tiny on these forms. So, etc., etc. 500, 600, 700, 800. Here's 900 right here in this little yellow line, and then we hit a megahertz. So that's how this paper works. This is 10K down at the bottom here. 10K, 20K, 30K, 40K, 50K, 60K, 70K, 80K. It just keeps getting tighter and tighter. Okay? Now, we take the 10 volts at 107. 107 is like right here in this region right here. 107, and we also have to label the vertical direction. Okay, so what about in the vertical direction? What do we got to do there? If we take a look at the scale again, we've got to develop a scheme that will get us what we need. And I'm going to make this here. Let me see, what color am I running here? I'm going to make my scale 0 right there. There's where my 0 dB point will be plotted. And I've got these major divisions, which I'm going to make 10 dB increments, okay? And you see that I quickly run into 40 dBs, which we won't need. So let's go back to the data, which we'll pick up a little color here in red. And 107 at 0 dBs is right here. Forgive my marksmanship. I want to do well, but my little drawing tool does not behave. Let's try this a little bit different and see if it works. There we go. Okay, that's the first point. Now, if we walk down to 99, we find out that, boy, 99 is really tight out there. And 99 is located right in, let's see, 99K is 17, and that's going to be 1, 2, 3. It's going to be somewhere down in this region. you with a pencil can do a better job than I with a computer touch unit here that I'm using. The next frequency that we look at dB as well. So that's somewhere 115, that's 10, that's 1, that's 10, 100, 110, 120. That's going to be right in this region here. And you see the points are tightly 7 dB. Well, 10K is right up on this axis right here at minus 37. That's going to be 40, 39, 38, 37 is right about here. Then 6 dB basically, minus 36. So there's 40, 35, 36, and it's right here. And you see this curve is starting to form. It doesn't matter that we're cropping off the end. We know it's minus 30. This is 10, 20, 30. This is 30K right here, bottom left. And minus, what did we say? Minus 30 in the overall accuracy of this thing. That puts us right here, 10, 20, 30, and that puts us right there roughly. And minus 30 at 400K. 100, 200, 300, 400 is right here. This is 400K. And we're at about minus, what did we say? 30, okay. Minus 30. So at 400K, we're at minus 30. And we have plotted our first Bode plot. So let's draw this in. Here it is. Here's our resonance spot. It comes down. It looks pretty symmetrical on both sides. So there you have it. Your first Bode plot on log, semi-log paper. Linear scale going up and down. Semi-logarithmic scale compressing the frequency. See, this filter response curve goes from 10,000 all the way up to 10 megahertz. That's why we compress the frequencies. And again, I'm going to say it again. You know, in the overall scheme of things, what's happening here where the blue circles are is pretty predictable. Once you've drawn a few points, you know, you can see that this thing's dying, going in either direction. So, thanks for listening.